Hello, and welcome to AP Environmental Science Chapter 18, Air Pollution. Dun dun. So, if we are going to talk about air pollution, we need to start off with a general understanding of what the air or the atmosphere is. Basically, we live at the bottom of an atmosphere that consists of multiple layers, and they're differentiated by density, pressure, and temperature. So, to start off, atmospheric density and pressure are congruently related. When we are at sea level, the density is high because there are more molecules per liter. But if you were to travel up to the top of the highest mountain, the density would decrease and the lack of particles would lessen the pressure. The first is the troposphere, where most of the Earth's air mass is found. It is the thinnest and also contains the air we breathe. It's followed by the stratosphere, which has the most ozone, the mesosphere, the thermosphere, and the exosphere. Take that, banana boat.
Now let's talk about what air pollution is. Air pollution is the presence of any chemical or chemicals found in the atmosphere in large enough concentrations to harm organisms, ecosystems, or human-made materials. These pollutants can come from both natural and human sources. Some examples of natural sources are wildfires, volcanic eruptions, and volatile organic material released by some plants. While these natural pollutants are spread all over the globe, they can be removed naturally by chemical cycles, gravity, and precipitation. Human sources are mainly found in urbanized and industrial areas where people, cars, and factories are concentrated. Most of the pollutants are generated by burning fossil fuels. There are two types of air pollutants: primary, secondary pollutants. The primaries emitted directly into the air, while the secondary pollutants mix with other air components to form new harmful chemicals. Now that we know what air pollutants are, here's a list of the major outdoor pollutants. 93% of carbon dioxide in our atmosphere is a result of natural carbon cycles, while nearly 2/3 of sulfur dioxide's presence in the air is a result of human activity. VOCs like methane, a greenhouse gas, are hydrocarbons. 1/3 of these emissions are natural, while the other 2/3 are human sources. There are 5 natural factors that can help reduce outdoor air pollutants. First, heavier particles settle out of the air due to the gravity. 2. Rain and snow help cleanse the air of pollutions. 3. Salty sea spray from the oceans help wash out the air of particulates that flow from land to water. 4. Wind sweeps pollutants away and dilutes chemicals by mixing them with cleaner air. And 5. Lastly, some pollutants are removed naturally by chemical reactions like SO2, sulfur dioxide mixing with oxygen, which falls as acid precipitation. Still, there are 6 factors that can increase air pollution. First, urban buildings can reduce wind speed and the dilution of pollutants. 2. Hills and mountains reduce the airflow in the valleys between them, which allow pollutants to build up on the ground. 3. High temperatures promote chemical reactions. 4. Emissions of VOCs play a large role in the formation of photochemical smog, which is a mixture of primary and secondary pollutants formed under the influence of UV radiation from the sun. 5. The grasshopper effect, which occurs when air pollutants are transferred from tropical and temperature areas to the Earth's polar areas by evaporation and winds. 6. Temperature inversions, where warm air layers sit atop cool air layers, cause pollutants to build to high levels because it restricts the air mixing and dilution.
What is acid deposition? Acid deposition is caused mainly by coal-burning power plants and motor vehicle emissions. Industrial plants in developed countries use tall smokestacks to emit sulfur dioxide, suspend particles, and nitrogen oxides high into the atmosphere where wind can mix, dilute, and disperse them. These tall smokestacks reduce local air pollution but can increase regional air pollution downwind. The primary pollutants, sulfur dioxide and nitrogen oxides, emitted high into the troposphere may be transported as far as 1,000 kilometers by prevailing winds. During their trip, they form secondary pollutants such as droplets of sulfuric acid, nitric acid vapor, and particles of acid-forming sulfate and nitrate salts. Particles remain in the atmosphere for 2 to 14 days, depending mostly on prevailing winds, precipitation, and other weather patterns. During this period, they descend to Earth's surface in two forms: wet deposition, consisting of acidic rain, snow, fog, and cloud vapor. Acid deposition is a regional air pollution problem in areas that lie downward from coal-burning facilities and in urban areas with large numbers of motor vehicles. Some areas in the eastern part of the United States receive rain that is at least 10 times more acidic than natural precipitation. To combat this problem, some soils contain basic compounds such as calcium carbonate or limestone that can react with and neutralize or buffer some inputs of acids. The areas most sensitive to acid deposition are those with thin, acidic soils that provide no such natural buffering, and those where the buffering capacity of soils has been depleted by decades of acid deposition. Acid deposition has a number of harmful effects. It contributes to human respiratory diseases and damages statues, national monuments, buildings, metals, and car finishes. Acidic particles in the air can also decrease visibility. One of the most alarming and often unseen effects of acid deposition is that it can leach toxic metals such as lead and mercury from soils and rocks into lakes used as sources of drinking water. These toxic metals can accumulate in the tissues of fish eaten by people, other mammals, and birds. Indoor air pollution is, for poor people, the world's most serious air pollution problem. First, levels of 11 common pollutants generally are 2 to 5 times higher inside U.S. homes and commercial buildings than they are outdoors, and as much as 100 times higher in some cases. Second, pollution levels inside cars in traffic-logged urban areas can be up to 18 times higher than outside levels. Third, the health risks from exposure to chemicals are magnified because most people in developed countries spend 70 to 98% of their time indoors or inside vehicles. The 4 most dangerous air pollutants in developed countries are tobacco smoke, formaldehyde, found in many building materials and household products, radioactive radon gas, which can seep into houses from underground rock deposits, and very small particles. Daily exposure to low levels of formaldehyde causes chronic breathing problems, dizziness, rash, headache, sore throat, sinus and eye irritation, skin irritation, wheezing, nausea, and eventually cancer. Indoor air pollutants include pesticide residues and lead particles brought in on shoes and collected in carpets. Living organisms in their excrements can also pollute indoor air, such as dust mites and cockroach droppings, which can cause asthma. Indoor air pollutants increase cancer risk and cause as many as 6,000 premature cancer deaths per year in the United States. At greatest risk are smokers, children younger than the age of 5, the elderly, the sick, pregnant women, people with respiratory or heart problems, and factory workers.
The body already has natural defenses against air pollutants, but they can be overwhelmed. The respiratory system has numerous ways to protect from pollutants. For example, nose hairs help filter out large particles. Mucus lining in the respiratory tract helps capture smaller particles and dissolve gaseous pollutants. Sneezing and coughing help expel the air and mucus contaminated by pollutants. And cilia, which is hundreds of thousands of tiny little hair structures that line the upper respiratory tract, wave back and forth, transporting mucus and the pollutants they trap to the throat where they can be expelled or swallowed. Prolonged or acute exposure to air pollutants can overload or break down these natural defenses. 17 million people in the U.S. suffer from asthma, which can be worsened due to air pollution exposure. Chronic bronchitis and emphysema, a disease with irreversible damage, can be contracted due to air pollution as well. Health and lives are at risk. According to the World Health Organization, 3 million people die each year from air pollution effects. And recent EPA studies show that 125,000 Americans get cancer from breathing soot from the diesel fuels from buses and trucks and other vehicles. Because of this, stricter emission standards for diesel-powered vehicles have been placed, which have predicted to reduce diesel fuel emissions by 90%. There are ways to tackle air pollution. Let's learn how to deal with air pollution now.
So, you've seen, heard, and read about the problems we face with air pollution. Now it's time to figure out a way to fix these conundrums. We could start with the regulatory approach with laws like these, which the U.S. has done a great job in encouraging, but there are also ways to make them better. First of all, we could focus more on prevention instead of just cleanup. We can increase fuel efficiency standards for cars and motor vehicles. We could create regulatory CO2 emission standards, and many more things. So a better, more effective way to deal with air pollution is to take it to the market. Don't buy from companies who pollute all the time and don't care. Promote those that try to reduce their footprint. Here are some other more specific ways to watch your footprint. Alright, so now that you have an idea of some ways how to reduce the air pollution in our world, let's put your mind to work, shall we?
Delhi wakes up to an air pollution problem it cannot ignore. For years, this sprawling city had the dirtiest air in the world, but few who lived here seemed conscious of the problem or worried about its consequences. Now, suddenly that has begun to change. Some among New Delhi's Indian and foreign elites have started to wear the white surgical masks so common in Beijing. The United States Embassy purchased 1,800 high-end air purifiers in recent months for staff members' homes, with many other major embassies following suit. Some embassies, including Norway's, have begun telling diplomats with children to reconsider moving to the city, and officials have quietly reported a surge in diplomats choosing to curtail their tours. Indian companies have begun ordering filtration systems for their office buildings. The increased awareness of the depth of India's air problem even led to Indian diplomats who had long expressed little interest in climate and pollution discussions with the United States officials to suddenly ask Americans for help in cleaning India's air late last year.
Thank you so much for watching. Until next time.